8421. Why are the rotor blades more efficient when operating in ground effect? A. Induced drag is reduced. B. Induced angle of attack is increased. C. Downwash velocity is accelerated. The correct answer is A. Rotor blades are more efficient when operating in ground effect because the induced drag is reduced. When a helicopter hovers close to the ground or any other surface, it experiences a cushioning effect known as ground effect. In this state, several aerodynamic factors contribute to increased efficiency, including the reduction of induced drag. Induced drag is generated as a byproduct of the production of lift by the rotor blades. When the helicopter is in ground effect, the presence of the ground alters the airflow patterns, resulting in decreased downwash velocity and reduced vortices created by the rotor blades. The reduced downwash velocity and vortices have the following effects on the rotor blades. Reduced downwash velocity. The ground effect causes the downwash velocity, or the speed at which air is deflected downwards by the rotor blades, to decrease. With a lower downwash velocity, the induced drag on the rotor blades is reduced, leading to increased efficiency. Reduced vortices. In ground effect, the vortices generated by the rotor blades are restricted by the proximity to the ground. This restriction reduces the interaction between the vortices and the rotor blades, further decreasing the induced drag. By reducing induced drag, the rotor blades can operate more efficiently in ground effect. This efficiency translates to improved lift production, reduced power requirements, and increased overall performance of the helicopter. Therefore, the reduction in induced drag is the main reason why rotor blades are more efficient when operating in ground effect. 8422. What result does a level turn have on the total lift required and load factor with a constant airspeed? A. Lift required remains constant and the load factor increases. B. Lift required increases and the load factor decreases. C. Both total lift force and load factor increase. The correct answer is C. The lifting power produced when a helicopter is positioned in a bank acts more horizontally and less vertically. The resulting lifting force, total lift force, must be raised in order to maintain a level rotation. Centrifugal force causes additional stresses to be exerted when a helicopter adopts a curved flight path. 8423. What causes a helicopter to turn? A. Centrifugal force. B. Horizontal component of lift. C. Greater angle of attack of rotor blades on upward side of the rotor disc. The correct answer is B. A helicopter turns primarily due to the horizontal component of lift generated by the rotor blades. As the main rotor blades rotate, they create lift by generating a pressure difference between the upper and lower surfaces of the blades. This lift force has both vertical and horizontal components. During forward flight or a turn, the helicopter tilts or banks in the desired direction. This banking action changes the direction of the total lift force. The vertical component of lift continues to support the weight of the helicopter, while the horizontal component of lift provides the turning force. By increasing or decreasing the collective pitch or cyclic pitch inputs, the pilot can control the angle of attack of the rotor blades on the upward side of the rotor disc. This adjustment helps to control the magnitude and direction of the horizontal lift component, enabling the helicopter to turn in the desired direction. Therefore, while centrifugal force and the angle of attack of the rotor blades on the upward side of the rotor disc contribute to the overall flight dynamics, the primary cause of a helicopter's turn is the horizontal component of lift generated by the rotor blades. 8424. What is the primary purpose of the tail rotor system? A. Maintain heading during forward flight. B. Act as a rudder to assist in coordinated turns. C. Counteract the torque effect of the main rotor. The correct answer is C. The primary purpose of the tail rotor system in a helicopter is to counteract the torque effect produced by the main rotor. The main rotor of a helicopter generates torque as it rotates, trying to spin the helicopter in the opposite direction. This torque effect is a result of Newton's third law of motion, which states that for every action, there is an equal and opposite reaction. To prevent the helicopter from spinning uncontrollably, the tail rotor system is used. The tail rotor produces a sideways thrust that counteracts the torque effect of the main rotor. By varying the tail rotor's pitch and rotational speed, the pilot can control the amount of counter-torque force and maintain the helicopter's heading during forward flight. While the tail rotor system does contribute to maintaining heading during forward flight, its primary function is to counteract the torque effect and provide control over the helicopter's yaw axis. It acts as a rudder, assisting in coordinated turns by providing yaw control and counteracting the torque produced by the main rotor. 8425. Under what condition would it be necessary to cause the tail rotor to direct thrust to the left on an American-made helicopter? A. To maintain heading with a left crosswind. B. To counteract the drag of the transmission during autorotation. C. To execute hovering turns to the right. The correct answer is B. Because there is no torque effect during autorotation, the drag of the gearbox tends to yaw the nose to the left in the same direction as the main rotor is moving. This is why tail rotors must be able to provide push to the left negative pitch angle.